Alright, this is section 6.3 and 6.4 put together. I think the topics lend well together, so that's why I did it this way. But if you want to split this up into two parts, you're more than welcome to. Let's look at investigation number 1. Hey, do you remember graphing out functions from Math 9? Please say yes. I heard you say yes. Why don't we try making a table of values so we can graph out these lines? So for our first one here, y equals 2x. I like to always choose values of x. I'm going to choose easy values, 0, 1, and 2. Yes. 2 times 0 then of course gives us 0. 2 times 1, when I plug in 1 for x, gives you 2 for y. And 2 times 2 is 4. So if I plot these points, 0, 0, 1, comma 2, 2, comma 4, and connect them together. Hopefully you have a straight edge. I'm just doing this by hand. But there's equation number 1. Yay! How about equation number 2? I'm going to use the same x values. This time I'm going to plug it in. So 2 times 0 is 0, plus 5 is, 5. 2 times 1 is 2, plus 5 is 7. 2 times 2 is 4, plus 5 is 9. Look what happens here. 0, comma 5, 1, comma 7, 2, comma 9. I get this line in red. And the third one, 2x minus 3 is the equation. Use the same x values. I hope you'll see that you get negative 3. 2 times 1 is 2, minus 3 is negative 1. 2 times 2 is 4, minus 3 is 1. What do we see here? Plotting these points. Dun, dun, I see another line. I hope you notice that these are all parallel lines. Right? And what do we know about parallel lines? They have the same slope. Yes, that was from the previous section. So that's kind of interesting. Same slope. I guess my question is, you see how this value, which I call b, that's really the number at the end. In this case here, the number at the end would be, I guess, plus 0. My question here for you is, how does this value of b change the appearance of the graph? So if you look at the 0, if you look at the 5, and you look at the 3, or the negative 3, down there, you could say that the actual b value shifts the graph. What was that? Shifts the graph up or down. And by the way, those values always are on the y-axis, so these are really the y-intercepts. That's, of course, where the graph crosses the y-axis. Okay. Let's try investigation number 2. Hey, this time, look what I've done. I've made that number always the same. And this time I've changed some other thing instead. So let's see how that changes things. Same idea as number 1. Let's choose some values of x. Let's plug it into our equation and find the values of y. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. 0, comma 1, 1, comma 2, 2, comma 3. Connect the dots. Ta-da! Number 1. Do the same thing for number 2 and 3. You don't need to wait for me. I know you know the drill by now, so go ahead and try it yourself. 0, comma 1, 1, comma 3, 2, comma 5. Connect the dots. Ding. And finally, this time 0, 1, 2. Negative 2 plus 1 is negative 1. Negative 4 plus 1 is negative 3. By the way, if I'm going too fast, just pause the video. graph number 3. Now look what happened this time. It doesn't look like that y-intercept changed. I did change the number in front of the x, in this case the 2, the -2, and the number in front of this x is, yeah, it's not there. Don't say 0, it's actually 1. So what does that do to the graph? And if you said it kind of changes the direction or the steepness of the graph, you are correct. It changes the steepness. Hey, what do we call the steepness again? Yeah, really, the idea is it changes the slope. So, in general then, in an equation that looks like this, y equals to some number or some constant we call m times x, adding to that another different constant called b, what do you think we have? Well, m really stands for yep, like in investigation number 2, it's the slope. And b stands for the y-intercept. And this is what we call the equation of the line in slope-intercept form. I should have wrote down form. Slope-intercept form of the equation of a linear function or a line. Alright? And that's what 6.3 is all about. Now in 6.4 we actually apply it. So I'd like us to try to apply something right away. Hey, remember what we had on the previous page again? Y equals to m times x plus b. M stands for the slope, the steepness of the line, and b stands for the y-intercept. So, example number 1, can you state the slope and the y-intercept for each of those equations? I'll do the first one. You do part B. Slope? Yeah, it's that value in front of the x, 5. Y-intercept? Yeah, it's that number at the end, -2. Your turn. Thank you, -1/5. Thank you, 6. Uh-oh, C looks a little bit different. What's going on here? Well, can we write it in this form? Can we make this look like that? We could, because we can write this as y equals to, now if there's nothing there except for the 3, that means there's nothing times x. So in this case, you could say now that the slope is actually just equal to, you got it, 0, and the y-intercept equals to 3. Cool. Alright, now I'd like you to actually take the y-intercept and actually draw a line with it with some given information. And then I think it says find the equations too. Okay? So, let's see. Starting with this point, 0, 4. That looks like the y-intercept. Right on. Draw a line with slope 2/5. What does that mean again from our previous section of learning? Yeah, slope is the rise over the run. So you can think of it as going 5 to the right for every 2 you go up. 5 to the right. 1, 2, 3, 4, 5. Every 2 you go up. Another dot there. 5 to the right. 2 go up. Another dot there. Connect them together. Bravo. There's your line for part A. Okay. Now it says also to find the equation of the line. Well, I gave you the slope. I gave you the y-intercept. This is the y-intercept since the x value is 0. So using my equation y equals mx plus b, m stands for the slope. That's just equal to 2/5. And b is the number 4. Ta-da! We're done. Okay. Alright, let's do part B. I'm going to change colors. Draw a line through -4, 5. Okay, so -4, 5. Sweet. And then it's a slope of -1/6. Oh. Oh, that's not so fun. But okay, negative 1 over 6. I prefer to write this as negative 1 over 6. So if this equals to my rise over my run, I always try to run to the right. So this is 6 to the right. But now it's negative 1 up, which really means 1 down. Okay? So the negative 1 here represents downwards. So I would take my point, I'd go 6 to the right. 1, 2, 3, 4, 5, 6, and 1 down. Boom. 6 to the right. 1, 2, 3, 4, 5, 6, 1 down. Boom. Connect them together. B. Whoa, what just happened there? Undo. Please come back. Good. Now, if you're thinking, can we find the equation of a line for this one? We could, but we'd have to estimate what that y-intercept will be. It's not a nice number. So for this part, I'm going to leave it for now. And I'm going to say I'm going to come back to it in a second. Okay? Come back soon. Don't write it down in your notes, okay? But I want you to realize that, like we just can't figure out the y-intercept right away. We might have to do some extra work. Okay? Alright. If I give you the picture, can you write out the equation of the line now? So if you look at number 3a, I think, can you really find me two things? Can you find me the slope and the y-intercept? If you got those things, you can find the equation of the line. So I'm going to look at the easier part here. It looks like this goes to the point 3, so the y-intercept is equal to 3. I like to do easy things first. What about the slope? Well, sometimes the slope's hard to see, but you might want to take 2 points on the line and then actually compare how you got from the first point to the second. In this case, I see I went 1, 2, 3, 4, 5, 6, 7 to the right. And I looked like I went 3 down, or negative 3. So my slope is my rise over my run. How about negative 3/7? So identifying these two things then allows me to find the equation of the line in the slope-intercept form. Here we go. Y equals to negative 3/7 x plus 3. Done. Okay, next one. I'm going to do the slope first this time. That looks a little bit easier. But you still have to find 2 points. I'm thinking, oh, that's a nice point. Right on the grid. Where's another nice point? Right on the grid. Boom, right there. This time I see 1, 2, 3 to the right. 1, 2, 3, 4, 5 up. Ooh. So my slope must be rise 5 over run 5/3. For this one though, like my previous example in 2b, it's kind of hard to find the y-intercept. Oh, it's not a nice number. Oh. Once again, I'm going to say, come back soon. Wait. We'll do this a little bit later. Okay? Wait. Be patient. Alright, moving on to the next page. How about you graphing out lines now? So, don't use the table values. This time I just want you to tell me the slope and the y-intercept and just graph it away. So, I always like to go from the y-intercept first. Look at 4a. What is the y-intercept? Oh yeah, negative 1. I'm going to start right there. Boom, there's my point. And then what does this slope thing tell us? The slope tells me the rise over the run. In this case, it's 2/3. So I'm going running to the right, 3, and then rising up 2. So from there, go 3 to the right, up 2. Boom. Connect the dots together. Oops, didn't do a good job. Connect the dots together. Yeah. Done. There's your answer, A. Okay? I want you to try B and see yourself. Okay? Pause the video right now. Do it, then come back and check my answers. Go. Did you pause? Don't cheat now. You're just cheating yourself if you didn't pause. See, I see the slope. That means, oops, not an x, just -1/4. 4 right, 1 down. Ooh, but no y-intercept. So that means it must be 0. So it must start at the origin. 4 right, 1 down. 4 right, 1 down. Connect. Beautiful. C. Okay. Feeling good about yourself? I hope you are. So I'm going to go do some more tricky stuff now. Example number 5. Okay. Let's do 5a. And, oh, by the way, and if you're separating this into 2 videos, I would stop right here and pause, do the questions related to 6.3, and then come back and watch the rest of this video to watch the rest of 6.4, and then do all the questions in 6.4. So example number 5 is a little bit different. Look what it says. It says draw a line through the point 3, -1. That's right here. And it says with a slope of -3. So once again, that's going to be 3 down, 1 to the right. 1 to the right, 3 down. Okay. And then it says, now find the equation of the line. But you're like, I'm not too sure if my line is correct. I can't really guess this point. So it's like those previous 2 questions I told you to wait. This is the time you're going to stop waiting. So if I ask you to find the equation of a line, I'm still going to use my y equals mx plus b form. Which one do we know right now, m or b? M, good. So we will rewrite this as -3x plus b. We need to solve for b. There are 3 different variables, x, y, and b. How would we solve for b? Well, we have another piece of information, don't we? We have a point on this line. And the idea of an equation of a line is that whatever values of x and y are on that line, it should satisfy that equation, meaning make the left side equals the right side. So if I were just to take this point and plug it in, I should be able to solve for b. So let's do it. -1 is the y value. 3 times 3 plus b. That's -9 plus b equals -1. I'm going to move the -9 to the side. b equals 8. So my equation is actually y equals -3x plus 8. Let's see if that makes sense with my picture. Maybe not. So what's going on? Well, I think I probably didn't draw it very well. Look. Remember how I said these 2 points? Yeah, I could have went the other way too. I always go 1 to the right, right? 1 to the right, 3 down. I could have also did 1 to the left, 3 up. Another 1 to the left, 3 up. And another 1 to the left, 3 up. And look at that. Oh, wow. It does match now. It actually, oops, I just need to draw it nicer. It actually does go through the y-intercept of +8 right here. Y-intercept. Yay! So guess what? In order for you to figure this out, and if you can't draw it nicely like what I did earlier, then you can use this method of plugging in the point and figuring it out. Okay? I'll do part B as well, and then I'm going to ask you to go, and part C, and then I'm going to ask you to go back to do those previous examples before I go on to the last page. So part B says draw a line through K, which is 5, 4. Here we go, 5, 4. That is parallel. Whoa. Parallel to the line in part A. What do we know about parallel again? Oh yeah, same slope. So that means also 3 to the right. Sorry, 3 down, 1 to the right. Boom. 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 This time, the y-intercept's off the chart, so you can't even use that graph to help you find it out. So, once again, y equals mx plus b. M is 3. How do we solve for b? That's right. Plug in the point on the line. 4 equals to negative 3 times 5 plus b. 3 times 5, that's 15, so this is negative 15. We're going to add 15 to both sides, so that's 19. So yeah, you're right, this is way off the charts, but that's okay. Negative 3x plus 19. Done. And once again, if I'm too fast, just pause the video. But I'm trying to save space or save time. Last one here. Still going through the point 5, 4. This time, perpendicular. What do we know about perpendicular slopes? Yes, they are the negative reciprocals. So if the original one was negative 3, what's the negative reciprocal of negative 3? That must be then positive 1/3, right? Negative 3 over 1. The reciprocal means you flip it, and then you take the negative of it. That becomes 1/3. So now I can say, hey, of my graph, 1/3, that means I go 1 up, 3 to the right, boom. And I can draw a line like this. And then now if I want to find the equation once again, this time using not negative 3 but positive 1/3 as my slope, and just like before, plugging in the point 5, 4. Oh, I see fractions. Uh-oh. Don't be scared. Oh, you are scared. That's okay. Subtract. Same thing, right? Same ideas. This time, do you remember how we have to find the common denominator? Oh, please say yes. Common denominator here is 3, so 4 times 3 is 12. The number 4 is the same thing as 12/3, or 12 over 3. And then, of course, once we found the common denominator, we can subtract. So 12 minus 5 is 7. Don't be afraid of fractions. Here is our final answer. 1/3 x plus 7 over 3. Done. Okay. Now, I'm going to pause. I don't want to hear myself anymore. Neither do you. I'd like you to go back now to page 2 and see if you can do all those 2 questions again now. Okay, this time by plugging it in. I will do it, but I want you to do it on your own, and then you come back and double check. All right? Do that now. Four sixths, that's the same thing as 2/3. I'm going to do some simplifying. So b equals to 5 minus 2/3. Oh, that's what, 15 over 3 minus 2 over 3. That's 13 over 3. So final answer, negative 1/6 x plus 13 over 3. Ooh, no y-intercept here either, right? Oh, bad news. But we do have a point. I'm going to use this particular point. Oh, oops. I touched something. I'm going to use this particular point, 4, 1. So y equals to 5/3 x plus b. I'm going to plug in 4 over 1. Sorry, 4, 1. Ooh, more fractions again, but that's okay. 1 minus 20 over 3 equals to b. Common denominator 3 over 3 minus 20 over 3 equals to negative what? I think I made a mistake here. Oh no! I just saw a mistake. Look, 1, 2, 3. Yes, 1, 2, 3, 4. No. Oh, nasty, 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 nasty. So sorry. Change all your work. Let's just start over. I'm glad we came back to this one. Why did you tell me earlier that it was wrong? Oh yeah, you couldn't. You're on video. 4/3 x plus b. 1 equals to 4/3 times 4 plus b. 16 over 3 plus b. 1 minus 16 over 3 equals to b. 3 over 3 minus 16 over 3 equals to negative 13 over 3. That seems more like it. So y equals to 4/3 x minus 13 over 3. Is that what you got? Good. And by the way, now I can answer the question. The y-intercept? Yeah, that's negative 13 over 3. All right. Woo. Last page. Ooh, got a few things here. All right. Number 6. Look at this. I'm missing something. This time I'm missing not the y-intercept but the slope. But the same idea. Because if you want to figure out the missing value, when there are 3 variables that are unknown, take your point and plug that in for x and y. So negative 13 equals to m times x. So m times negative 2 plus 5. We can subtract 5 on both sides, so you get negative 18, and just rewrite this as negative 2m, right? Multiplication. 3 times 4 is the same thing as 4 times 3. The order doesn't matter. But I think for algebra-wise, people like having the number in front. And then finally, to do this, to solve for m, the opposite of multiplying is dividing. So negative 18 divided by negative 2 is just positive 9. And there you go. Done. Okay. All right. Kumon Plus. We all heard of Kumon, right? Now there's something called Kumon Plus. You pay a membership fee of $25, and then you add a monthly fee of $14, and hey, you're set to learn as much math as you want. I'm going to ask you to see if you can connect this to what you did maybe in a previous unit, like Unit 5. It says, write an equation for the total cost for n months at the Math Center. So remember, your cost here is a membership fee, which is something you pay once, and a monthly fee that you pay for every single month. Because you are going for n months, if you went for 1 month, you'd pay $14. If you went for 2 months, it'd be 14 times 2. If you went for 3, it'd be 14 times 3. So you went for n months, it'd be 14 times n. Okay? Hey, by the way, this is a linear equation, right? If I asked you just to tell me what the slope and the y-intercept would be, I know I didn't ask you, but if I did now, the slope would be, 14, and the y-intercept would be, 25. Good. Suppose my son went to the Math Center for 2 years. Yikes. Lots of time. Oh, by the way, 2 years, months, make sure you're in the same units. So 2 times 12, that's 24 months. How much did it cost? A lot, you say. 14 times 24. Plus, don't forget the original membership fee of $25. What's 14 times 24? Oh yeah, $336. Yikes! Plus, don't forget 25. Yeah, $361. Wow. And if the total cost was $515, how many months did it actually go? Or did my son actually go? So now I'm saying take $515 and make that the cost. And this time you need to solve for the number of months, which is n. And so to do this, hopefully you remember the algebra skills you learned from Math 9. I'm going to subtract 25 from 515. 490. And then finally divide both sides by what? 14? Yeah. 490 divided by 14, I know this. That's 35. So how many months? 35 months. That's almost 3 years. Wow. Alright, we are very near the end. The last equation or example here. Woo! 8 examples. I know. If you watch this all in one sitting, that's a long time. Good for you. Bravo. If you'd watched it in 2, that's what I would have done. So the line represented by y equals 3x minus 2 and a line perpendicular to it intersects at the point 1, 1. Find the equation of the other line. It says a line perpendicular to it. So once again, where's my slope again here? Yeah, the slope is the number 3 or 3 over 1. So the perpendicular slope would be what? Yeah, the negative reciprocal. Good. So it says that the other line is perpendicular, so it has this slope, negative 1/3, and is also intersects, so it goes through this point. Well, I think we have all we need now. Y equals mx plus b, right? M stands for the slope. B stands for the y-intercept. We don't have the y-intercept, but we do have a point that goes through this line, so plug in the point. Plug in point. I have a feeling that fractions are here again. Negative 1/3 plus b equals to 1, so b equals to 1 plus 1/3. That's just 3/3 plus 1/3, or you got it, 4/3. So y equals to negative 1/3 x plus 4/3. And we're done. And you can try these questions here.